Good morning, dear children. Welcome back to our online math class. Okay, which lesson is being taught nowadays? Yes, nowadays we have been dealing with the lesson multiples and factors, isn't it? Okay, in this lesson we have gone through many concepts. Which are they? Do you remember? Can you say? Yes, factors of a given number, multiples of a given number, then prime number, composite number, unique number and so on, isn't it? Okay, and in our previous class we discussed the factor tree method for finding out the prime factors of a given number, isn't it? We discussed the factor tree method for finding out the factors of a given number. Okay, please don't write, just listen carefully. According to this factor tree method for finding the prime factors, what we have to do? Yes, suppose if we have to find out the prime factors of the number 14. For that, what shall be done? Yeah, we have to write this 14 as a product of two numbers, isn't it? How can this 14 be written as the product of two numbers? Yeah, we all know 2 sevens are 14, isn't it? 2 sevens are 14. So, we can write 14 as the product of 2 and 7, okay? Okay, then after that what we have to think? Yes, this process has to be continued until reaches prime number. So what about 2? Is 2 a prime number? Yes, 2 is a prime number. So we can stop, or we have to stop here. What about 7? Is 7 a prime number? Yes, 7 is also a prime number. So we have to stop here also. So we can say that 2 and 7 are the prime factors of 14, isn't it? All these have been discussed in our previous class, isn't it? Do you remember? And then what about the number 12? How can we find out the prime factors of 12 by factor tree method? Yeah, we have to think, how can we write, or how can this 12 be written as the product of two numbers? How can we write 12 as the product of two numbers? Please try to say. Many ways are there. Please try to say which are the ways for writing 12 as the product of two numbers. Can you say? Try to say. Yeah, very good. We can write 12 as 2 into 6. 2 6 are 12. Okay, yes, good. Any other way? Yeah, we can write 3 4s are 12. This is also a way for writing 12 as the product of two numbers, isn't it? Okay, any one of these can be chosen. Finally, we all will get the same answer. Either you can choose this way or you can choose this way, no problem in that. Finally, all of us will get the same answer. So, I would like to choose this here. So, we can write 12 as the product of 2 into 6, isn't it? So, this has to be continued until it reaches a prime number. Okay, so let's consider our first number. What about 2? Is 2 a prime number? Yes, 2 is a prime number. So we can stop here. What about 6? Is 6 a prime number? Is 6 a prime number? No, 6 is not a prime number. 6 is not a prime number. So we can't stop here. We can't stop here. So we have to continue this. We have to continue this. Okay. Now, what we have to do? Yeah, we have to think, how can this 6 be written as the product of two numbers, isn't it? How can we write 6 as the product of two numbers? 6 can be written as? Yes, very good. 2 3s are 6, isn't it? 2 3s are 6. So 6 can be written as 2 into 3. Now, what about these 2 and 3? Is 2 a prime number? Yes, 2 is a prime number, so we can stop here. What about 3? Is 3 a prime number? Yes, 3 is also a prime number, so we can stop here. So, we have got the prime factors of the number 12. Which are they? 2 and 3. No need to write 2 twice. So, which are the prime factors of 12? 2 and 3 are the prime factors of 12, isn't it? Hope you understood this very well. We have done many problems also in our previous class, isn't it? Okay. Now we are going to discuss a very important method for finding the prime factor. This is not this factor tree method is not the common method or the important method for finding the prime factors of a given number. That is of course an easier one, but in your higher classes you should know another very important method for finding the prime factors of a given number. Okay. Now we are going to learn a very important topic named prime factorization. Prime factorization. Please don't write, just listen carefully. Now we are going to learn the topic of prime factorization. Prime factorization means the method for finding out the prime factors of a given number. The method for finding out the prime factors of a given number is known as prime factorization. Prime factorization. And let me explain how to find out the prime factors of a given number. So here we are going to find out prime factors of 12. For this, we have to divide this number like this, not the usual division. The number has to be divided like this. Okay, so first consider 12, and before start doing this, please write down the prime numbers between some prime numbers on the working column. First prime number 2, then 3 is for a prime number? No. 5, yes. 6, no. 7 is a prime number. 8, no. 9, no. 10 is not a prime number. 11 is a prime number. 12 is not a prime number. 13 is a prime number. Okay, let's write up to this in the up to 13. 2, 3, 5, 7, 11, 13 are the first 6 prime numbers. Please write down these numbers, prime numbers, in the working column. Now we have to start thinking with the smallest prime number 2. This is very important. We have to start dividing with the smallest prime number 2. So we have to begin with 2. Consider 2 first. Can we divide this 12 by 2? Is 12 divisible by 2? Yes, 12 can be divisible. 12 is divisible by 2. Why? 12 is an even number. So we have to choose this 2 itself. Okay. So we have to begin with this 2 itself. We can divide 12 by 3 of course, but that cannot be chosen. First we should think about the smallest prime number 2. If it is not possible, only we are allowed to move on to the next prime number. Is it clear? Okay. So now think 2 which are 12. 2 which are 12. Usual division 2. We are going to divide 12 by 2. 2 which are 12. Yes, 2 6 are 12. Okay. But here we can't stop the division here. Why? Any idea? The reason is this division has to be continued until it reaches a prime number. So until we get a prime number, we have to continue this division. This division has to be continued. So can we stop here then? No, we can't stop the division. Why? Yes, this division has to be continued until reaches a prime number. Here 6 is 6 a prime number? Not at all. 6 is not a prime number, so we can't stop here. We have to continue this division. So let's continue. Again start from the first prime number 3. Again we have to divide. So again consider the first prime number 2 itself. First prime number 2. Can we divide 6 with this first prime number 2? Can we divide 6 by 2? Yes, we can divide. 6 is an even number, so we can divide 6 by 2. So again 2 itself. 2 which are 6. 2 3s are 6. Isn't it? 2 which are 6. 2 3s are 6. Can we stop the division here? Of course, we can stop the division here. Why? Why? Yeah, 3 is a prime number, so we can stop the division here. So which are the prime factors of 12? Yeah, here we have 2. 2 is repeated twice, so no need to write it twice. 2 is a prime number and 3 is also a prime number. So 2 and 3 are the prime factors of 12. Understood? 2 and 3 are the prime factors of 12, and 12 can be written as the product of 2 into 2 into 3. 2 into 2 into 3. 12 can be written as the product of the prime numbers 2 into 2 into 3. Have you understood? Got it? Now let's try one more. Now let's consider the number. Now let's consider the number 45. Here we are going to find out the prime factors of 45. Here we are going to find out the prime factors of 45. And here also, in all the problems where we are finding out, where we try to find out the prime factors, we should start thinking with the smallest prime number 2. That's very, very important. We have to start thinking with the smallest prime number 2. So start thinking with 2. Can we divide 45 by 2? Can we divide 45 by 2? What is the rule of divisibility by 2? Last digit should be an even number. Here the last digit is 5. It is not. Is 5 an even number? No. So can we divide 45 by 2? No, we can't divide 45 by 2. So division by 2 is not possible. So we can't choose 2. Now what we have to do? Yes, now we have to move on. Now we have to move on to the next prime number 3. Next prime number 3. And think, can we divide 45 by 3? Can we divide 45 by 3? How to find out whether 45 is divisible by 3 or not? What is the rule of divisibility by 3? What is the rule of divisibility by 3? Sum of the digits should be divisible by 3. In 45, what is the sum? 4 plus 5. Yes, 9. Is 9 divisible by 3 or is 9 in 3's table? Yes, 9 is there in 3's table. So we can say that 45 is divisible by 3. So this can be chosen. Okay. Now listen carefully. 3 which are nearest to 4. 3 which are nearest to 4. Yes, 3 ones are 3. 3 ones are 3 only, isn't it? 3 ones are 3 only. Here we have 4, isn't it? Here we have 4. 3 ones are 3. Here we have 4. So 3 after 4 balance 1. Balance has to be written above. 3 after 4 balance 1. Understood? Is it clear? 3 ones are 3. 3 ones are 3 only. But here we have 4. 3 after 4 balance 1. 3 ones are 3. Here we have 4. So 3 after 4 balance 1. That balance has to be written above this 4. Understood? Now keep this 1 and 5 together in mind. 1 and 5 together. Keep this 1 and 5 together. It becomes 1 minute. Keep this 1 and 5 together in mind. It becomes 15. Okay. Now 3 which are 15. 3 which are 15. Yes, 3 5. This can be done in the working column. Okay. 3 which are 15. 3 5s are 15. 3 5s are 15. 3 which are 15. 3 5s are 15. That 5 has to be written down. 3 5s are 15. Okay. If you want, you can strike out 5 and write 15 like this. Then 3 which are 15. 3 5s are 15. Or it will you will get confused if you write like this. Better do like this itself. In the working column you can do 3 which are 15. 3 5s are 15. That 5 has to be written here. Understood? Okay. Can we stop the division here? No. Why? 15 is not a prime number. Very good. So we have to continue the division. Now we need not consider 2 here. Why? In the first case, 2 we found that this number cannot be divided by 2. So we have to start thinking from 3. Can we divide 15 by 3? Is 15 divisible by 3? Yes, 15 is there in 3's table. So we can divide, isn't it? Okay, 3 which are 15? Yes, 3 5s are 15. Can we stop here? Yes, we can stop. Why? Yeah, 5 is a prime number, so we can stop. So which are the factors of 5? sorry, 45, 3 and 5. 3 and 5 are the factors of 45, and 45 can be written as the product of, yes, 3 into 3 into 5. 3 into 3 into 5. This is the method of factorization, method of prime factorization. Have you got understood? Okay, now let's start writing the prime factorization. Write down prime factorization. Prime factorization. While doing the problems, the concept would be more clear to you. Okay, prime factorization. Write down, very important, this is very, very important. The method for finding out the method for finding the prime factors, method for finding the prime factors, the method for finding the prime factors of a given number, method for finding the prime factors of a given number is called, what is the method? Yeah, is called prime factorization. Prime factorization. Okay, write down. Continue writing. In this method, the division has to be started. The division has to be begun, that is better than begun. Begun, began, begun. Past participle of begin is begun. Has to be begun with the smallest prime number 2. Begin with the smallest prime number 2. Begin with the smallest prime number 2. If it is not possible, we have to we shall move on to the next prime number 3. Smallest prime number 2. Smallest prime number 2. If this division is not possible, if this division is not possible, we shall move on to the next prime number. What is the next prime number after 2? Yeah, 2 after prime number 3, isn't it? We shall move on to the next prime number. Next prime number 3. Next prime number 3. This division has to be continued until reaches a prime number. This process, here not able to write, children. Let me rub. This process has to be continued until reaches a prime number. this process has to be continued until reaches a prime number. It's very important. This process has to be continued until reaches a prime number. Okay, understood? Have you understood the method of prime factorization? Okay, I think it's, time is up now. We shall wind up this class now. These problems regarding the prime factorization shall be done tomorrow. Then the concept will be clear to you. Hope you understood the class very well. Thank you. Have a nice day.